of least stable conformer of ethane. So conformers of ethane you can represent by two ways. One is called Newman projection, and this carbon is called front carbon. If two hydrogens are one behind the other, this is rare carbon. The circle represents the carbon behind the viewer. The Y intersecting point of Y represents carbon just in front of the viewer. So two carbons are one behind the other. So it is CH3 single bond CH3. So if I catch this and push like this, one CH3 will be facing you, another CH3 is behind you. If one hydrogen is behind the other, it is called eclipsed form. Now this eclipsed form has a dihedral angle of 0. The angle between the front plane and back plane is called dihedral angle. So here 0. If it is rotated 60 degrees, this will remain constant, the front carbon. The hydrogens will move like this, then the dihedral angle is 60. It is called staggered. This is called eclipse. These are called conformers. And the isomerism is called conformational isomerism. These conformers or conformational isomerism arises due to the free rotation of carbon-carbon single bond. Now the next question. Noble gases are named because of their inertness towards reactivity. Identify an incorrect statement about them. Noble gases are sparingly soluble in water. That is correct because they are non-polar. Water is polar. How a non-polar can be slightly soluble in a polar solvent? So for the first option, you have to write due to induced dipole-dipole attractions. Due to induced dipole-dipole attractions. Second option, noble gases have very high melting and boiling points. This is absolutely wrong. Because they are gases, they do not have high boiling and melting point. You know the boiling point of helium, liquid is 3 Kelvin. 3 Kelvin means the temperature in centigrade will be minus 270 degrees. So helium exists in liquid state at what temperature? Minus 270. So you have to convert helium into its liquid state at minus 270, then you have to boil. Then also it will be negative temperatures. So they have very low boiling and melting points. Noble gases have weak dispersion forces, that is also true. Noble gases have large positive values of electron gain enthalpy. Because they have a stable octet configuration. If you add an electron, they don't accept. You have to provide energy for the electron. Generally, usually, whenever an electron is added to an atom, the atom gains that electron and release energy. So delta H is negative That is called electron gain enthalpy. But in noble gases, because of their stable configuration, they don't accept electrons. You have to provide energy. So their electron gain enthalpies are positive. Next one, the major product in the following chemical reaction. So it is isopentene. This group is called iso. CH, again CH, double bond CH2. For this, they added HBr in the presence of C6H5 CO twice O2. So this is benzoyl peroxide. So what is the name of this? Benzoyl peroxide. So whenever HBr is added to an alkene in the presence of peroxide, we call it as an anti-Markovnikov's addition. So first you have to write, this is an example of anti-Markovnikov's addition. Anti-Markovnikov's addition. This anti-Markovnikov's addition involves free radical mechanism. So it involves, you have to write the next point, it involves free radical mechanism. So in the free radical mechanism, you know the OO bond is called peroxy bond. The peroxy bond equally breaks. It is called homolysis. So what you will get? Two free radicals you will get. 2C6H5 COO dot. So whenever homolysis, the covalent bond breaks into two equal parts, it is called homolysis or simply homolysis. Homolysis always results in the formation of free radicals. Now this free radical attacks the HBr which we added. In HBr also, here the bond undergoes homolytic bond fusion. You will get H free radical, Br free radical. Free radicals are species containing single electrons. They are paramagnetic. They are highly reactive. So this part will take the H dot. So you will get C6H5 COOH plus Br free radical. Now this Br free radical, in the next step, I am changing the page. Now this is what we have taken. Now Br free radical attack the alkene. What it is? Isopentene. What is the IUPAC name of this? 3-methyl-butene. What is the IUPAC name? 3-methyl-butene. But 1-ene. Ene position also you have to say. When Br free radical attacks, the pi bond also undergoes homolytic bond fission. So when it undergoes homolysis, this carbon gets dot, this carbon gets dot. Correct? Homolysis always gives dot to both. Now Br can attack the first carbon, or Br can attack the second carbon. Two possibilities are there. Let us say this is path 1, this is path 2. Suppose if path 1 is followed, CH dot CH2Br, you will get a secondary free radical. You know, free radical stability, carbocation stability follows same order, tertiary greater than, secondary greater than primary. Both are explained by same reason, that is plus I effect or hyperconjugation. Yesterday we discussed that point. Now the secondary free radical stable react with HBr and take the H, forming 1-bromo 3-methyl 1-bromo 3-methyl butane. This is numbering 1, 2, 3, 4. First position is bromo. Third position is methyl. 1-bromo 3-methyl butane as the major product. Suppose if path 2 is followed, this is path 1. If Br attacks the middle carbon, then you will get a primary free radical. This is primary free radical, which is unstable or less stable. This again react with HBr. H will take. So you will get a different product. CHBr, CH. 2-bromo 3-methyl butane. This is a minor product. This is a major product. So here just you are recollected what is Markovnikov's rule. In Markovnikov's rule, unsymmetrical alkenes are treated with HBr. It is an unsymmetrical alkene because if you cut the double bond, you are not getting equal halves. Suppose if I take ethene, CH2 double bond CH2. It is what? Symmetrical alkene. If we take 2-butene, 2-butene. It is also symmetrical alkene. So for symmetrical alkenes, Markovnikov, anti-Markovnikov's rules are not applicable. Sometimes the question asks like that. For which of the following Markovnikov's rule is not applicable? They will give 4 options. So what you have to identify? A symmetrical alkene, it won't apply. Now, write a point. If peroxide is not used, the HBr addition to an unsymmetrical alkene, if peroxide is not used, HBr addition to an unsymmetrical alkene follows Markovnikov's rule in which a more stable carbocation intermediate is formed. And Br minus adds to the doubly bonded carbon having, and Br minus adds to the doubly bonded carbon having less number of hydrogens. So that also will take the same example. So CH3 twice, CH double bond CH2. I am adding HBr, H plus Br minus. I am not using any peroxide. Without peroxide, it follows what rule? Markovnikov's rule. So HBr addition only follows either Markovnikov's rule or anti-Markovnikov's rule. Anti-Markovnikov's rule is also called peroxide effect or Karash effect. Peroxide effect or Karash effect. Now without peroxide, actually this is a plus I group, electron pushing nature. The pi bond will shift like this. Because the methyl groups push electrons, the pi bond will shift. This carbon become negative. H plus will add to that. Because of that, you will get a carbocation, a secondary carbocation, CH2H. So stable secondary carbocation. To which the Br minus is added here. So finally the product is CH3 twice, CHBr, CH. This is the product. This is the major product. So if you look at the starting compound and the end product, you can simply visualize H is added, Br is added. H is added here, Br is added here. It is an addition. So we simply say the previous slide and this slide. Here Br is added to doubly bonded carbon with more number of hydrogens. Next, here Br is added to doubly bonded carbon with less number of hydrogens. So again I repeat, in anti-Markovnikov's, Br is added to, these are two doubly bonded carbons. This doubly bonded carbon is having two hydrogens. This doubly bonded carbon is having one H. So if you look at the final product, Br is added to which carbon? Doubly bonded carbon having more number of hydrogens. If you come to this point, Br is added to doubly bonded carbon having less number of hydrogens. That is a simple observation. So here in this context, if you take an alkene, if you treat with H2 in the presence of nickel, you will get alkane. If you treat with HBr, H and Br are added. Like this, additions occur. If you treat with hypochlorous acid, in which OH minus, Cl is plus, H plus, Br minus. So here you will get pi bond will break, OH is added to one carbon, Cl is added to another carbon. If you add HCN, same principle, remove the pi bond, add H to one carbon, Cn to another carbon. If you add bromine in CCl4 medium, so two bromines are added. You will get a dibromoethane. If you add water in the presence of H plus, Dr. Tony, yesterday you asked this. World supply of ethyl alcohol, 75% of ethyl alcohol in the entire world come from this reaction. Ethylene to ethyl alcohol. If you treat with ozone, H2O, Zl, the double bond breaks, 2 moles of formaldehyde you will get. If you treat cold alkaline KMnO4, cold dilute alkaline KMnO4, it is called Bayer's reagent. What is the name of this reagent? Bayer's reagent. Actually, this is called hydroxylation. So two OH groups are added. So I will write in a different way. Cold dilute alkaline potassium permanganate. It is called Bayer's reagent. Now this reaction is called hydroxylation. So the pi bond will break, 2 OH groups are added. It is called ethylene glycol. Actually, this bromine test and this Bayer's reagent test. Write a note. Addition of bromine or Bayer's reagent to form colorless addition products. Addition of bromine or Bayer's reagent giving colorless addition products. Is an example of test for unsaturation. Is an example of test for unsaturation. Actually, bromine is reddish brown in color. Reddish brown. The product is colorless. Here this is pink color. This is colorless. So whenever a particular organic compound is given, so you can do whether it contains double bond or not, simply add bromine. CCl4 acts as a medium because bromine is highly pungent, odors you can't inhale. So bromine is dissolved in CCl4. The reddish brown color bromine is added to ethylene gas, or ethylene gas is passed through it. Immediately it becomes colorless. That is due to the formation of a dibromo derivative called 1,2-dibromo-ethane. With Bayer's reagent you are getting ethylene glycol. What is that? CH2OH, CH2OH? Ethylene glycol. Yesterday we discussed in Wolff-Kishner reduction. We are using ethylene glycol as a medium. It is a high boiling solvent. So, one more thing. High temperature, high pressure catalyst. You will get CH2, single bond CH2, N times, called polythene, a plastic. Polythene is a plastic. So these are all alkene reactions. So alkenes undergo what type of reactions? Electrophilic addition reactions. All these are examples of what? Electrophilic addition reactions. The previous chapter, alkanes undergo what? Free radical substitution reactions. So alkanes undergo FRS. Alkenes undergo electrophilic addition, EA. Alkynes also undergo electrophilic addition. Benzene undergoes EAS, electrophilic aromatic substitution. So in the 11th portion, organic chemistry, you have hydrocarbons, alkanes, alkenes, alkynes, benzene. 4 types of hydrocarbons are there. Undergo FRS. Alkenes undergo electrophilic addition. Alkynes also undergo electrophilic addition. Benzene undergoes EAS, electrophilic aromatic substitution. Your job is done. Okay. Next is Firat. The incorrect statement among the following: actinoid contraction is greater for elements to element than lanthanoid contraction. See classroom notes, we discussed this point. Because 5f orbitals have very less shielding effect than 4f orbitals. Thus the electrons in the 5f sublevel, one f electron cannot effectively shield the other f electron. That's why the actinoid contraction is more pronounced than lanthanoid contraction. Same usage, same point you observe in the notes. Most of the trivalent lanthanoid ions are colorless in the solid state. This is wrong. Because tripositive lanthanoid ions contain unpaired electrons in the f sublevel, which absorb light and jump into lower energy orbital to higher energy orbital. That involves absorption from visible light. Whenever we from visible light VGR, a particular wavelength is absorbed. The remaining 6 wavelengths appear in the form of a new color called complementary color. So that's why the ions of D block in solid state, that is in the form of salts. Solid state means in the form of salts. If you take cupric sulfate salt, blue color. If you take ferric chloride, reddish brown. If you take ferrous sulfate, light green. If you take cobalt chloride, dark blue. If you take manganese chloride, pale pink. So like that, many D block salts you have studied in your practical chemistry. They are colored. Same thing applicable for, yes. So most of the trivalent lanthanoid ions are colorless in solid state is wrong. They are colored. Lanthanoids are good conductors of heat and electricity because they are metals. Actinoids are highly reactive metals, especially when finely divided. That is also correct. Because the lower series of lanthanoids and actinoids, they resemble alkali metals. The heavier elements resemble like aluminium. They are very reactive metals. So the next one, out of syllabus, solid state. Identify the compound that will react with Hinsberg reagent to give a solid in which dissolves in alkali. So here you need some explanation. Primary, secondary, tertiary amines are distinguished by Hinsberg test. In which you should know Hinsberg reagent. Hinsberg reagent is benzene sulfonyl chloride. Benzene sulfonyl chloride. Now you have 3 test tubes. Let us say we don't know which test tube contain which amine, but separately 3 amines are present in 3 different test tubes. You have to identify which one is primary, which one is secondary, which one is tertiary. So you add Hinsberg reagent to all of them. So if it is primary amines are characterized by RNH2 group. They react with Hinsberg reagent. HCl is eliminated. This is primary amine. Minus HCl. You will get RNH, SO2, C6H5. It is called N-alkyl benzene sulfonamide. N-alkyl benzene sulfonamide. Actually, this H present on N due to electron withdrawing oxygens. This H becomes acidic. That's why it will react with a base alkali. So after removing the H plus, you will get RN double bond S C6H5. No need of double bond. When you write double bond, the number of bonds are becoming 6. So this become N minus after H plus is gone. Suppose if it is KOH, N minus K plus. You will get a soluble salt. Soluble salt. So primary amines react with Hinsberg reagent. What is Hinsberg reagent? Benzene sulfonyl chloride. First the HCl is removed. You will get N-alkyl or N contain R group, N-alkyl benzene sulfonamide. Now this N-alkyl benzene sulfonamide, the N contain a H atom. The NH bond pair will be pulled by N, and also sulfur, adjacent sulfur, is having 2 strong electron withdrawing oxygens. So overall electrons are dragged by these atoms. H is ready to become H plus. That's why I mentioned it is acidic hydrogen. Whenever H is going to become H plus, it is called acidic hydrogen. That's why this acidic hydrogen is removed by a base, resulting in a soluble salt. I did not understand that. Who asked? Even it is in silent mode also. DeepSeek, Google Gemini, chatbot AI, 3 artificial intelligence tools are available nowadays. People can utilize them in a good way. Just I wanted to check the Chinese DeepSeek, and yesterday I put a question. Tell me about Arunachal Pradesh. Then it says it is beyond my scope. I don't know. Because then immediately I ask, tell me about the Indo-Chinese War of 1962. Where the Chinese Communist government banned all these sensitive things. It says, this is beyond my scope. And the third question I ask, so tell me about Tiananmen Square. There is one Beijing, big square is there. And the Chinese Communist Party, students protested against Communist Party. Many students gathered in the big square and they are protesting peacefully. So the Chinese Communist government could not digest it. Immediately they ordered the army to roll tanks on them. So many students died. That is a very black mark in Chinese history, recent history. So that I know. That's why I want what answer it will give. Then also it says I don't know. But when I asked these same 3 questions in Google, Gemini and other AI tool, they are giving full length details. Because they are from Western countries. DeepSeek is a Chinese. So actually we can utilize effectively the tools. You can also misuse. Both you can do. So it is up to you. So we are like a stone. The stone can be sculpted by ourselves into a very good shaped sculpture or remain as a stone. It is up to you to become good or bad. Okay. So now my job is very simple. What I am doing, here I am removing this, H also I am removing, and writing R2NH, and I am writing secondary amine. Secondary amine, let us say the first test tube is giving a soluble salt. So this is primary amine, confirm, because it is giving a water soluble salt. So now, when secondary amines are treated with benzene sulfonyl chloride, so you will get NN dialkyl, N, N dialkyl. Dialkyl benzene sulfonamide. If you treat with a base, because there is no replaceable H, there is no acidic hydrogen. If you treat with a base, do not react or insoluble. same compound you will get there. So secondary amines only react with benzene sulfonamide, that is Hinsberg reagent. But after that it won't react with base. Insoluble means no action. Now I am moving on to tertiary. So what I will do, I will remove one more H. And put one more R, and I mention it as tertiary amine. So when tertiary amine is treated with benzene sulfonamide, Hinsberg reagent, no action, because there is no replaceable hydrogen. So how do you distinguish primary, secondary, tertiary amines? By Hinsberg test, we had add Hinsberg reagent. What is Hinsberg reagent? Benzene sulfonyl chloride. Next question. Which of the following reactions of metal displacement reaction? Choose the right option. Only in the second option, chromium is displaced by aluminium. So this is called Goldsmith's aluminothermy process. Goldsmith's aluminothermy process. Or it is also called thermit welding. So in thermit welding, metal oxides like chromium oxide, manganese oxide, iron oxide, these are reduced by aluminium. Actually, they will take in 3:1 ratio metal oxide versus aluminum powder. They take in 3:1 ratio, and this mixture is called thermit. Now it is ignited. Ignited with barium peroxide plus magnesium ribbon. Then it become Al2O3. If oxygens are taken away by aluminium, 2 chromiums are left. So here also Al2O3, 2Fe. Here also Al2O3 plus Mn. But here we have to balance oxygen. If you multiply with 4, 12 oxygens. If I multiply with 3, 12 oxygens. Then I have to write 9 manganese, 8 aluminiums. So in all these reactions, Delta H is negative, highly exothermic. The metal will be in the molten state. Molten metals are obtained. So actually, if you see the tracks, railway tracks, if a particular rail is broken, they weld it instantly by using the same technique. So there is a small vehicle, wheel moving vehicle. People will just push it, on rails it will easily move. They reach the exact place. They put a red flag that they are doing some work, so that the incoming driver will notice that. So they take metal oxide, aluminum powder, ignite. The metal will get in liquid state. The liquid is poured between the broken parts of the rails. They immediately melt and attach with each other. This is called thermit welding, highly exothermic reaction. Actually, aluminum burning itself in air is highly exothermic. Next. The next one is again out of syllabus, chemistry in everyday life. What is the IUPAC name of the organic compound formed in the following reaction? This just in the previous day we discussed. Formaldehyde plus Grignard reagent followed by hydrolysis give primary alcohol. Other than formaldehyde, any other aldehyde plus Grignard reagent give secondary alcohol. Ketones plus Grignard reagent give tertiary alcohol. So here you will get a tertiary alcohol, 2-methyl butane 2-vol with acetone. So acetone you take acetone, it is treated with ethyl magnesium bromide, C2H5, MgBr. This is minus, this is plus. It is called nucleophilic addition. So you will get CH3, CCH3, C2H5, OMgBr. So this on hydrolysis, H plus OH minus. This gives CH3, OH. This I am expanding C2H5 into CH2CH3. Then it will be easy for you to name IUPAC system. 2-methyl 2-butanol. 2-methyl 2-butanol. It is a tertiary alcohol. So ketones with Grignard reagent always give. This is an example of nucleophilic addition. Aldehydes, ketones undergo nucleophilic addition. Aldehydes and ketones undergo nucleophilic addition. Just now we discussed alkenes and alkynes undergo electrophilic addition. Alkenes and alkynes undergo electrophilic addition. Carbonyl compounds, that is aldehydes and ketones, undergo nucleophilic addition. So if you write RCH/R, double bond O. What is this? If you read it as a H, it is aldehyde. If you read it as R, both are R's, it is ketone. So here I am writing aldehyde or ketone. Or ketone. They react with the sodium bisulfite with HCl, hydrogen cyanide, with alcohol, with water, with Grignard reagent. With ammonia. So with sodium bisulfite, you will get RCH slash R. This become OH. This become SO3Na. The OH minus will add to the SO3 minus will add to the carbon and H will add to the oxygen. Similarly, HCl. In HCl, what is the nucleophile? Cn minus. That will add to the carbonyl carbon. So the product is RCH slash R Cn OH. The name of the first compound is aldehyde sodium bisulfite or ketone sodium bisulfite. Simply names you have to add. If you consider it as aldehyde, aldehyde sodium bisulfite. If you consider it as ketone, ketone sodium bisulfite. This is aldehyde, aldehyde or ketone, cyanohydrin. With water, RCH or water is H plus OH minus. So in all these the pi bond will shift, plus charge will add to the O, minus charge will add to the carbon. Same mechanism in all these. Negative charged species is called nucleophile. So the nucleophile adds to the carbon. Positive charged species is called electrophile. Electrophile will add to oxygen. So here the OH will add here, another OH, you will get a gem diol. Gem diols are unstable. Is treated with excess of alcohol in the presence of concentrated HCl. In the presence of concentrated HCl, acetols are formed. Acetols are those compounds in which two OR groups are attached to same carbon. That I will write separately because no space. So here R minus MgBr plus. So RCH, H or R. This O become OMgBr. This on hydrolysis will give RCH R R OH. OMgBr become OH. With ammonia, I can write H plus NH2 minus. H plus will add to O, NH2 minus will add to carbon. You will get aldehyde ammonia or ketone ammonia. These are all nucleophilic additions of both aldehyde and ketone we studied. Here, two important exam points are there. Two important points we can put together and form a single question in the form of assertion reasoning type. Write assertion. Aldehydes are more reactive than ketones. Aldehydes are more reactive than ketones towards nucleophilic addition. Aldehydes are more reactive than ketones towards nucleophilic addition. Reason. In ketones, due to plus I effect of two alkyl groups, due to plus I effect of two alkyl groups, and also steric hindrance. And also steric hindrance. Is responsible for the less reactivity. Is responsible for the less reactivity. So that I will show here. RCH double bond O plus nucleophile R C double bond R plus nucleophile. So first one is aldehyde, second one is ketone. Here the reaction is fast. Here reaction is slow. So in both cases, the nucleophile is added to carbon. So why it is slow? That is the question we have to discuss. To attack the nucleophile, the carbon should have more positive charge. If positive charge is more, nucleophile can easily attack. Here the positive charge is less, because after shifting the pi bond, some positive charge is developed on the carbon, which is decreased by the plus I effect of two alkyl groups. Alkyl groups are electron pushing. So when two alkyl groups push electrons towards the carbon, the net positive charge decrease. Without much positive charge, nucleophile can't attack fast. That's why relatively nucleophilic attack will be slow here because of less positive charge. Why it is less positive, why it is more positive? Because here two plus I groups, alkyl groups, are decreasing the positive charge. Second option, here both alkyl groups, they occupy more space. So the nucleophile can't easily approach steric hindrance. Here only one alkyl group cause steric hindrance. Hydrogen is very small atom. It won't cause any steric problem. So the approach is more here. The approach is less here. Why the nucleophilic approach is difficult here? Due to steric crowding. That's why if you write, hope you understand this, if you write, in case of aldehydes, in aldehydes, decreasing order of rate towards nucleophilic addition. Formaldehyde is highest. Next is acetaldehyde. Next is propionaldehyde. Next is butyraldehyde. This is the decreasing order of reactivity. Why formaldehyde is the most reactive? Because there is nobody to decrease the positive charge on the carbon. Both are hydrogens. Hydrogens do not cause any plus I effect. But with increase in the size of alkyl group, plus I effect increases. When plus I effect increases, electron pushing nature increases, the positive charge on the carbon decreases. That's why nucleophilic attack becomes slower and slower. And also with increase in the size of alkyl group, the steric factor also increases. Steric factor means it is nothing but occupying in the space. That is called steric factor. So in case of ketones, the highest reactive is acetone or propanone. So with increase in the size of alkyl group, this is butanone or 2-butanone. This is pentanone. Which is more than hexanone. So these are towards nucleophilic addition. So 61 question. Acidic strength increase in the order. Correct. As the size of the element increases down the group, the bond strength of HF, HCl, HBr and HI decreases, and so the acidic strength increase. Very clear question. No suspicion, no thinking. So in case of HI, bond length is more, bond can be easily broken, H plus can easily come out. So both are true. The next one is a factual. Cp minus Cv is equal to R. Specific heat at constant pressure minus specific heat at constant volume is equal to gas constant. Next is again a direct question. PC alpha has trigonal bipyramidal shape. SF4 is having, SF6 is having octahedral. BRFI is square pyramidal. MX5 type of interhalogen compound. BF3 is trigonal planar. In PC alpha, sp3d hybridization. SF6, sp3d2. In BRF5, sp3 d2 again. Correct? 5 bond pairs, 1 lone pair. BF3 sp2. Next. The following solutions were prepared by dissolving 10 gram of glucose in 250 ml of water. P1, 10 gram of urea in 250 ml of water. P2, and 10 gram of sucrose in 250 ml of water. P3. The right option for the decreasing order of osmotic pressure of these solutions. Osmotic pressure pi is equal to CRT. C is molar concentration. So pi is equal to N by V into RT. Number of moles by volume is molarity. Or N is equal to, N is equal to weight by molecular weight. So the same formula, pi is equal to W by M into 1 by V into RT. Now here, W is equal to same. All are 10 grams, 10 grams, 10 grams. V is equal to same. R is same, constant, at same temperature. So when all these are constant, this entire lot is constant for all the three solutions. So pi is inversely proportional to molecular weight. Pi is inversely proportional to molecular weight. So what are the substances? Molecular weight of glucose. Its molecular weight is 180. Molecular weight of urea. Is equal to 60, I think. 4 plus 12, 16. 16 plus 28. 44 plus 16, 60. Molecular weight of sucrose, 342. So which is having highest molecular weight, that will have more osmotic pressure. Inversely proportional. (342) correct? C12, H22, 11. Yes. So based on this, P2, what is P2? Urea is having least molecular weight, then its osmotic pressure will be more. Urea is higher than, glucose is higher than sucrose. That is the answer. Actually, next one is out of syllabus, metallurgy. But you can write, zinc is a low melting solid. In the 3D series, or first transition series, the last element zinc has very less melting point because of completely filled orbitals which do not participate in metallic bonding. We discussed already in the D block elements in the notes. You see a curve also, melting point curves also we have given. So that's why zinc is a low melting solid. It is purified by distillation. Next, tritium is the radioactive isotope. Actually here you have to write lighter radioactive isotopes are beta emitters. So it emits a beta particle. Beta particle is nothing but electron. Then the atomic number increases by 1 unit, mass number remains same. You get helium-2,3 isotope. So tritium after beta emission, what it will give? Helium-2,3. Next question. Body centered cubic unit cell, solid state, no. Next, the major product formed in the dehydrohalogenation of 2-bromopentane to give pentene 2. Yesterday we discussed already Saitjev rule or Zaitsev rule. Discussed or not? The maximum temperature that can be achieved in a blast furnace, again metallurgy out of syllabus. Next, Ferrat 70. EDTA is a hexadentate ligand. Ethylene diamine. Tetraacetate. You can also write O minus like this. You can expand and write like this also. So total it can form 6 coordinate covalent bonds by donating 6 lone pairs. That's why it is a hexadentate ligand. Actually more than 2 we call polydentate ligand. Polydentate ligands form chelated complexes. Polydentated ligands form chelated, means ring compounds, which are very stable.